Hello again, everyone. This is Week 1, Lesson 1, continuing Part 2, focusing on our next step, location, location, location. How do geographers identify where places are on Earth? Location, location, location. In geography, it helps to understand that location can be described in either absolute terms or relative terms. Absolute location is the exact spot on Earth where something exists. Absolute location is usually expressed according to a system of imaginary numbered lines that crisscross the globe. You will read about these lines below. Relative location is the general position of where something is in relation to other things. For example, the United States could be described as being south of Canada and north of Mexico. Knowing the relative location of a place can help shed light on the characteristics of that place. For example, suppose someone tells you the city of Rome is situated in Italy on the Tiber River near the Mediterranean Sea. You now have some information about the water resources available to the city for fishing, trade, and transportation. If you are familiar with Italian culture, you can guess that the language of the people of Rome speak and perhaps what the main religion is. Relative location may not be as specific as absolute location, but it can still be valuable. Let's take a look at understanding location and how it describes latitude and longitude, absolute and relative location.
One set run north and south and are called lines of longitude. The other set run east and west and are called lines of latitude. Lines of latitude are also referred to as parallels of latitude. Since they are evenly spaced, about 69 miles apart, exactly parallel to each other. Around the middle of the Earth is a line called the equator. The half of the globe above the equator to the North Pole is called the Northern Hemisphere. The lower half of the globe below the equator to the South Pole is called the Southern Hemisphere. The word hemisphere means half of a globe or sphere. The lines of latitude are shown on this globe at every 15 degrees. This is the symbol for degree. Notice that this 15-degree marking has an N after it. That means that it is 15 degrees in the northern hemisphere. If you went south, the 15-degree line in the southern hemisphere is the same distance from the equator, but in the southern direction. You would say your latitude is 15 degrees south. Each degree can be further broken down into minutes. There are 60 minutes in 1 degree. This is the symbol for minutes. Minutes can be broken down into even smaller measurements known as seconds. There are 60 seconds in 1 minute. This is the symbol for seconds. Let's put it all together. 60 seconds equal 1 minute. 60 minutes equal 1 degree. Let's move on to the lines of longitude. The lines of longitude run north and south around the globe, meeting at the north and south poles. Unlike the lines of latitude you've learned about, the lines of longitude are not evenly spaced apart. At the poles, they come together, and at the equator, they bulge apart. Lines of longitude, or meridian as they are also known, begin at 0 on the prime meridian. The prime meridian is also known as the Greenwich meridian, as it runs through the original site of the Royal Observatory in Greenwich, England. This globe shows them at 15-degree intervals as they intersect the equator, but at the poles they are only labeled every 30 degrees since they are so close together. Lines of longitude are measured in the same way the lines of latitude are, with degrees, minutes, and seconds, all keeping their same meaning and symbols. Just like the zero line of latitude, the equator, divides the Earth into the northern and southern hemispheres, the zero line of longitude, or line of meridian, divides the Earth into the eastern and western hemispheres. Just as you specified northern and southern hemisphere with latitude, you will now give east or west to locate the correct lines of longitude. You've seen the prime meridian at 0 degrees, but as it circles the Earth and comes to the other side, it is now located at 180 degrees on what is known as the International Dateline. Before we move ahead to the line, let's come back to the question about locating Guatemala City, Guatemala. Could you find Guatemala City now if you were told it was located at 15 degrees north and 90 degrees west?
I think so. Well, here's 15 degrees north, and here's 90 degrees west. There it is.
That's it exactly. Nicely done. You'd find Baton Rouge, Louisiana, exactly the same way. It is located approximately 30 degrees north and 90 degrees west.
Understanding the difference between relative location and absolute location is quite easy to understand, and this video really cements the point.
Location is where it is in relation to another place. We might say that Windsor is south of Richmond, but to find Windsor we need to know where Richmond is. This can cause problems if there is more than one Richmond, or worse, if there is more than one Windsor. If we want to avoid confusion, we can give the absolute location of a place, its latitude and longitude. You often see lines of latitude and longitude on a map of the world or a globe. The lines of latitude indicate how far north or south a place is away from the equator, and the lines of longitude tell us how far east or west a place is from the Greenwich meridian, an imaginary line that travels from the North Pole to the South Pole via Greenwich in England. The main advantage of using absolute location is that each location has its own unique bearings. Richmond, British Columbia is 49 degrees 10 minutes north, 123 degrees 10 minutes west. Richmond, Ontario is 45 degrees 11 minutes north, 75 degrees 50 minutes west. Richmond, England is 52 degrees 24 minutes north, 1 degree 44 minutes west. And Richmond, New South Wales is 33 degrees 35 minutes south, 150 degrees 30 minutes east.
Aids to reading maps and understanding why some maps look different from others. A map is just a flat drawing that shows the feature of an area, and it is a key tool for geographers. Some maps show natural physical features like mountains, lakes, oceans, and continents. There are 7 continents in the world: Asia, Africa, North America, South America, Europe, Australia, and Antarctica. Maps can also show other kinds of information, including political boundaries, population, roads, rainfall, votes that are cast in an election, and much more. Different types of maps have a different purpose. However, a good map will generally include 3 basic things to help the readers use it properly: a compass rose, which is showing north, south, east, and west, a key or a legend explaining the symbols on that map, and a scale, which is showing the breakdown in distance.
Legend will show what the symbols on the map stand for. For instance, a solid line may be used to show borders between countries. A star might indicate the capital of a country, and a solid dot may represent major cities. A map scale is used to show how distances on the map relate to real distances on Earth. Many map scales have an upper and lower section. The upper might show distance in miles, and the lower one might show it in kilometers. You can find the distance between two places by measuring the distance between them on the map and then comparing it to the scale. One technique is to mark the distance on a piece of paper and then bring that paper to the map scale for measurement. A map may show a neighborhood, a city, a state, a country, or even the entire Earth. When a map is used to show the Earth, problems result. The reason is that a map is a flat representation of a planet that is a sphere. So on a map, things will not be the proper shape and size. That's because you can't take a round object and flatten it out without distortion. Think of an orange with a map of the Earth drawn on it. The map on the round orange will look very close to the real thing, our planet. But when we try to peel the skin of the orange off to make a flat map, things begin to look strange. It would be hard to use this map because of the empty spaces between the sections. So map makers use methods of map projection to make their maps. They are drawing the curved surface of the Earth onto a flat surface. There are different ways to do this, but all ways will have some distortion. That means they won't be completely true or accurate. Here is a popular map called a Mercator projection. The lines of longitude have been drawn in such a way as they don't join at the north or south poles, as they would on a globe or the real Earth. The areas at the poles have been stretched, which makes the images at the poles much bigger than they really are. For example, look how Greenland appears bigger than South America, when in truth it is much smaller. And look how Antarctica looks compared to its real shape and size on a globe. On this map, shapes appear to be correct, but size is not.
All right, class, that is the end of the video lecture for Lesson 1. We need to take a few moments to review some important vocabulary. Your vocabulary is going to be due at the end of the week, as seen on our Schoology link in your listed assignments. Let's take a moment to review absolute location and relative location. Look at your notes. Can you clearly identify what is the difference? What is the difference between latitude and longitude? If you're still having questions, this is the time to review your lesson. This week you need to remember you need to answer your discussion board, your vocabulary is due, and you also need to review your in-class activity as well as your homework. Remember, if any questions arise, please send an email or blog to a peer.